All right, so the whole idea of the talk is basically that you can take something back home to improve security of your own apps. I'm just using Elasticsearch as an example because that's the code base I'm most familiar with. I've been working on that code base for 6 years before switching teams, so I hope I can tell you what we did and why we did it in a couple of examples. So yeah, I'm Alex, I work for Elastic. I've been working from home since 7 years, so I can't imagine working from an office anymore. It's great. If you have questions about that, ping me afterwards. Elastic is a distributed company. We are now like 1,800 people or something scattered across the globe, which is not fun in terms of time zones, but it's really nice in terms of seeing each other every now and then. And I want to talk about Elasticsearch. Given the fact that all of you know this already, we can have a pretty quick introduction to what Elasticsearch is. Basically, it's part of the Elastic Stack, and the Elastic Stack can be considered some sort of building blocks to solve a certain kind of use case. This could be something like Wikipedia. Everything you type into Wikipedia goes against Elasticsearch, or an e-commerce product search engine, or something for your log data, your APM data. And just depending on what kind of use case you have, you can pick between the different components of the stack. Like tailing a log file is probably FileBeat, storing in Elasticsearch, having a dashboard in Kibana, and so forth. The thing we want to take care about today is Elasticsearch, like the center of the stack, being the component storing the data, being the component being queried all the time. And Elasticsearch at its core is a search engine. You can use it for things like full-text search, think Wikipedia, analytics or geo-based search, or you can combine all of those together. It tries to be near real-time, which basically means once you index data, this data should be available for search as fast as possible. It's distributed, so you can run it on one node or on hundreds of nodes. It's highly available and resilient. Resilient in this term means that it kind of figures out by itself if a node is not available and makes sure it takes proper countermeasures to ensure that the data is available across your cluster without you having to intervene. The interface is HTTP and JSON. The whole idea behind this is basically that you know HTTP as a protocol, that you know JSON as an object notation. So the technology is new, but the way you talk to the technology is not new for you. And it's kind of the center of the Elastic Stack. And my uneducated conservative guess, which is not backed up by any formal claims, is that there are kind of tens of thousands of clusters worldwide. And one cluster contains a number of instances, though there are hundreds of thousands of instances running, or maybe millions. And this means this system has a big attack surface, right? If someone finds a security hole, there's the potential that the security hole is really, can be used in a lot of systems. So security is super vital to us to think about whatever we do, whatever kind of feature we add, security really comes first. We can't just add a feature and hope it's secure. So that's the plan for today. I want to talk about security, what is this? Is this a feature? Is it a non-functional requirement? I want to talk about the Java Security Manager. Who of you is a Java developer or has to deal with Java as part of operations? All right, I'm going to go to another question soon. I expect no hands going up. I also want to talk about something which is not security, but still important from a usability perspective. And that is the fact that even if you don't control the execution environment, like we don't with Elasticsearch, you can just download it and run it on your own premises. We want to make sure that when you run it in production, certain conditions are fulfilled in order to make Elasticsearch fast and safe to run. And the last two parts are plugins and scripting languages, which we will hopefully cover as part of the talk. So, feature or non-functional requirement. So, security as a non-functional requirement usually means that someone really smart is trying to tell you that software has to be secure. That's a great statement, but also essentially really useless. If you ask a developer, people are like, yeah, you have to do defensive programming, whatever. If you ask a business person, people are like, don't persist specific data. If you ask business development, you don't want to store credit card data because you have to get an expensive certification for that. And some people are going to tell you that their software is not exploitable. That's a great statement. It's just not going to happen. Then there's sort of practical people telling you, yeah, I don't want to have any unintended resource access. And there's a wonderful CVE, and I think it's from Miele, from 2017, I think, where Miele issued a CVE telling you, we fixed the directory traversal attack in a dishwasher. And you sort of read the CVE and you're like, what the hell? Why is there a web server in my dishwasher? And Miele said they fixed it, which is great. But you could probably just have removed this friggin' web server and not have any security issue in the future, right? So it's always a question of how do you want to solve a security problem. There's always more than one way to do it. It's like Perl, right? Then there are a couple of more things like the least privilege principle, reduced impact surface, so in case something goes wrong, you can't take over the whole system or all of the components, these kind of things. And then there's security as a feature. And this is something I do not want to cover today. This is all things that Elasticsearch supports, like authentication, authorization against different backends, TLS, audit logging, single sign-on. So this is more for me like the integration part of things. But this is not what makes a system fundamentally secure. This is more about how a system interacts with other systems, how you can put Elasticsearch into your enterprise environment, and it still works as intended with things like single sign-on. Also, the borders are kind of blurry. Sometimes a feature is really hard to categorize. This is also really bad because of the German language, because the German translation for security or safety is both Sicherheit, which makes things sometimes really blurry, especially in German documentations. So things like integrity checks, for example. An integrity check, if you want to make sure that there's no bit flipping on your hard disk, that's definitely a safety or resiliency feature. If you want to make sure no one fiddled with your TLS packets and you do integrity checks on top of that, that's a security feature. So depending on how you implement this, it serves different purposes. Preventing out-of-memory exceptions in Java. Like, those are horrible, we all know. The first thing you should do is probably restart the process. But if you prevent this, like, is this a security or safety feature? Given by the spec that the behavior after an out-of-memory exception in Java is undefined, and you could probably read things that you're not supposed to read, it's a security feature. Given the fact that your application just keeps up and running, that's a safety or resiliency feature, right? It's hard to tell. Not exposing credentials in your configuration, or if you have something like a configuration file and you also have an API on top of that, you want to make sure that you don't expose passwords, usernames, and these kind of things. That's a clear security feature. Who of you has an application that is writing to disk? Okay, everyone else is doing things in memory. That's great. Do you have a test that tests how your application behaves if you're running out of disk space? Okay, one person. The rest just has infinite disks. This is amazing as well. I can cope with that. But for Lucene, for example, the underlying library that Elasticsearch is using, there was no guarantee that data could not be corrupted. So Elasticsearch stops writing data at some point, right? And you should test this behavior. It's really important. If you don't know what your application is doing, you may end up with corrupted data and all your data is gone. Who of you knows, or who of you has something like a scripting language or the ability that your customer can upload custom code to your product? Okay. If the customer uploads code that is executing system exit to exit the JVM, will this be caught? Do you have a test for this? It's not a lot of hands. All right, so think about this, right? System exit is a bad system call, right? You want to guarantee that your service is up and running, so you want to make sure that your customers cannot call system exit, no matter if they're able to execute arbitrary code, which they hopefully aren't anyway. All right. You can categorize system or security problems in a really nice way. You may know this wonderful citation from Donald Rumsfeld as his reasoning to invade Iraq for the second time, and he was talking about known knowns, known unknowns, and unknown unknowns, and that's actually a great analogy for security issues. They are the known knowns, where people just come up with something like file permissions. If I read in the documentation, in order to make something more secure, don't make this file like readable for everyone. Like, this is the wrong approach, right? Don't tell people what to do. Just put your distribution out in a way that everything is as secure by default. But do not create useless documentation that people are not going to read anyway. Known unknowns. Could be something like you have a scripting language and someone finds a security issue. The ability to execute arbitrary code, the ability to read a configuration file that he's not supposed to read. These kinds of things. I consider those application level exploits. If you knew about them, you would have fixed them. The moment you knew about those, you're going to fix them. And then we have the unknown unknowns. This is something like 2 years ago, Spectre, right? Like, someone comes up during the Christmas holidays, which is absolutely great for these kind of exploits, and telling you, look, the CPU branch prediction is broken. We can read everything we want. And you as an application developer sit in front of your JVM and think, well, shit. Right? There's not much you can do. You just have to wait until the next patches are coming up and flowing. So those are things you're never, ever going to expect. Let's talk about the JVM security manager. Who of you, of all the people who held up their arms when running Java, has ever used the Java Security Manager or has done this system call in his code? Hands up. There's 2. That's actually way more than anywhere else. It's great. So before we talk about the Security Manager, let's talk about what a sandbox is. So the basic idea of a sandbox is that you have code that executes and you do system calls, right? The Linux or the operating system, the kernel, translates your code into system calls. One of them could be, I want to connect over the network to this host. And from an Elasticsearch perspective, this is a perfectly valid call, right? Because a distributed system needs to connect to all of the other nodes within a cluster. I want to write to the log file. That's a perfectly valid system call. It's great that Elasticsearch is able to log things, right? I want to know things when they go wrong. I want to delete a file because the data has been cleaned up or removed. That's a perfectly valid thing as well. So from an operating system perspective, those are just system calls. And this is also just a system call, right? Open etc password is just reading a file from the operating system. From a user perspective, if my Elasticsearch code is executing this, something went horribly wrong, right? I don't want anyone to read etc password or etc shadow. Downloading this Bitcoin miner and executing it, it's just a system call, right? It's also just connecting over the network, getting some bytes, writing them to disk, and executing them. From a user perspective, this is absolutely not what should ever happen. Same for unlinking all of my data. It's a bad thing, right? If someone finds a way to delete all of my data within the Elasticsearch cluster, that's not what I want to happen. So the idea is, from a user perspective or from a developer perspective, you put something around your code, which again can decide, this is a malicious call, this is a friendly call, right? This one is allowed, this one is blocked. And this is exactly what the Java Security Manager is about. Who of you still had who of you wrote Java applets, like for a living? Wow, people are old, great. So I only had those in university, and Java applets is basically what JavaScript is today. You download code from somewhere in the internet, just like when you open up your browser and open a web page, and it gets executed locally. It's basically the absolute security nightmare, right? It's not what you want to happen, yet we are all used to this, that this happens all day long. So the idea of Java back then was, okay, if I wrap this into a sandbox, that looks kind of secure. So I basically only allow certain calls which are defined with something called a policy, and the rest is rejected. That's the whole idea. Basically, you explicitly have to allow things when the security manager is enabled in order to be able to open a file or even read a file, in order to open a network connection and this kind of thing. And this way, you could basically contain the Java code that is running as an applet. You just had a very strict policy, and if that policy was violated, you could sort of decide what should be done. Usually, you may want to just exit the process. And basically, the security manager is part of the JVM execution. You have this outside policy there, and the policy basically contains the list of different permissions that are allowed. Like for Elasticsearch, this would be reading the configuration directory, writing to the log file path, and connecting to arbitrary nodes over the network. This is then part of the JVM. And this way, basically every system call or lots of system calls that are executed are matched against this list of allowed policies. So if you take a look at Java, this is the Java IO file class, which of course no one of us is using because everyone uses NIO. But you can read here that there's an additional check which retrieves the configured security manager and just checks, am I allowed to read this file? And if I'm not allowed to read this file, it basically throws a security exception, that's it. So you can consider it just an additional wrapper, and if you go back, the system security manager, this one will return null if it's not configured, so the JIT compiler can optimize this away, so you don't have to eat any additional performance penalty. Okay, if I had more time, I would be giving here a demo by just enabling and disabling the security manager and showing you a couple of examples. The most fascinating demo of this would be that you can define a variable to be public, static, and final in Java, which means it should not be changed in any way, but using reflection, you actually can change it. So you can change the state of your application if you don't notice it, and this variable contains something important, like the calculation from euro to dollar and vice versa, and someone is able to change this value by a factor of 10 and then doing something funky like an account transfer. You can do really interesting things. And now you might want to blame this on reflection, but the Java language specification explicitly states that changing static final fields is a perfectly fine thing to do, right? So there's not a bug, it's just a feature within the language that you have to deal with. So imagine the security manager protects you from these kind of things. Of course, as usual, there are drawbacks, right? You can't just enable security and everyone is happy. Like I saw 2 people raising their hands that have dealt with the security manager, and the other, like 98% haven't. And there's a reason for that. First, by default, you have to hard code the policies before startup. That's chicory, right? Most of the time, you don't know which path you're going to write your data to or read your log files. You usually just read a config file and then decide what you want to do. For a Java applet, this was fine. For a server-based service like Elasticsearch, this is not. By default, DNS lookups are cached forever. This doesn't sound like a big problem, but on the other hand, running in a cloud environment where AWS at any point can decide that some endpoints change over time, this is a problem. Running in your own data center, this usually is not. And now we come to the fun part. This was already mentioned in the keynote this morning. Like, people stop thinking about the dependencies or the dependencies of the dependencies, right? And with the security manager enabled, you have to know what code are your dependencies actually executing. Is your transitive dependency using reflection or not if you disable it? Like, what happens when you run in production and it's disabled? And the biggest problem is that many libraries are not tested with the security manager enabled, which means you're running completely unknown code paths if the security manager is enabled. This happened to us. We were adding this feature to Elasticsearch, and we had Netty as a dependency for networking. And Netty never ever heard of security manager. So we ran a completely different code path in our own CI than on the Netty CI. And that, of course, is a problem. And it's not a protection against everything. It's just a protection for certain calls that are being made. But you can still run out of memory. You can still create a Stack Overflow. And you have to make sure you deal with those. There's a certain kind of granularity for your configuration that you have to keep in mind. And there's no protection against Java agents. Java agents is basically a mechanism which is standardized within Java that you can change the loaded bytecode again in order to add monitoring features or any other kind of features. So it's sort of a preloading mechanism. And this preloading mechanism can do pretty much whatever it wants. All right, we're going to talk in a second about how Elasticsearch uses the Java Security Manager. Let's just talk about a couple of more things here, like the least privilege principle, how this is implemented in Elasticsearch, how we implemented that we really want to make sure you don't run Elasticsearch as root, but on the other hand, we don't control the execution environment, right? How do we ensure that you can't run Elasticsearch as root on your notebook? Like, obviously, we can't hack it, so we have to find some other mechanism there. We also really don't want to fork a process. Like, when we fork a process in Elasticsearch, that's for us a clear sign we've been hacked. So the best thing that could happen to us is don't fork a process. You don't want to expose sensitive sacklings. I think that's kind of a standard approach. I won't cover that today. And the first thing I want to talk about is the security manager in Elasticsearch. And the whole idea here is basically that there's some initialization work going on before Elasticsearch is being started and before the security manager is being started, because Elasticsearch needs to read its configuration file. There's a YAML configuration file where there's the path stored where the data is written. There's a path stored where the log files are written, these kind of things. We also need to execute a bunch of native code. I will talk about that in a second, what that is. But native code means we have native and Linux system calls, which we can protect, or we want to make sure that the security manager is not yet active, because this kind of calls is something that should be prohibited after startup. And the whole idea is basically start with an empty security manager. This is what every Java application is doing by default. Do all of this fancy initialization work, and then enable it. And this is basically what it looks like. There's the JVM startup, which means you're loading the classes, you're finding the main method, then Elasticsearch reads the configuration file. We do all of those fancy native system calls. We set the security manager. Then we are loading plugins. I will talk about plugins in a second. It's basically extensions that you can write for Elasticsearch. Then there are Bootstrap checks. I will also cover those. And only if everything here was successful, we're going to enable the network, and that's the moment when Elasticsearch is basically able to talk to other nodes within a cluster. So it turns out we had to adapt the existing security manager, because the default security manager is still optimized for this Java applet world, which fortunately doesn't exist anymore. But for example, in Java applets, the best thing that could happen is if this malicious code from someone else is calling system exit 0, right? Because that means the JVM process is finished, which usually means it's now really secure. If there's no process, there's no security problem. For us, it's a bad thing, right? If someone was able to exit the JVM, Elasticsearch would not service anymore. That's something we really don't want. There's a couple of more securities around threads, thread pools, thread groups, and you can also add your own permission. This is, for example, what we did for scripting. So whenever there's a script executed, script means it's code from someone else, we're going to have to pass a specific security check. And if that check is not passed because someone found a way to execute a script somehow where it's not supposed to be executed, the execution would break and stop. Also, there's a dedicated ES policy, which basically loads the data from the configuration file and also for each plugin. I will talk about that later. There's also something called a Bootstrap check. This is a check on startup, which makes sure that a certain condition is met. In this example, there's one specific permission called the all permission, which basically allows everything from a security perspective. So you could have spent 3 days setting up your security policies, then someone really smart comes up, set this permission, and everything is allowed. That sounds like a really useless permission, but it makes a lot of sense because if you enable this permission, you can also create some sort of logging and tracing. You can see what kind of permissions are needed when your code is running. But when Elasticsearch is running in production, we don't care for this. We really want to make sure that this permission is not set. And if you ever configure this permission somehow, Elasticsearch will not start. All right. Who of you ensures that in their own code, the system cannot be run as root? That's a solid 0. I think it's important because if your system gets hacked and you're running as root, basically you got a system takeover. And the code for this is actually really short because all you have to do is a single native call. This is basically the code within Elasticsearch that is required to check if the service is running as root. You can see at the top that we unfortunately cannot reliably check this under Windows. But we can just call the get EUID system call under other operating systems. And if that one is returning 0, we are running as root. And if that's the case, we just abort startup. Like, we don't care if you really would like to run Elasticsearch as root, we will abort, and that's it. Right? And this is all the code that is basically required on our side. We could argue in this position, of course, that if someone was really smart and has another user with another UID that has all the capabilities under Linux, he would be able to run code again. But I still need to meet a lot of people who have their administrative user under Linux not set to UID 0. Who of you knows what Seccomp is or has heard of Seccomp? Oh, that's nice. It's actually a lot of people compared to when I talk about this. So the idea of Seccomp is to prevent, or is the ability to set a security policy. And the reason why we wanted to use Seccomp was basically to prevent process forks. I just said, like, when there's a process being forked in Elasticsearch, that's a problem. We know we've been hacked. And one of the assumptions we made is because no one is using the security manager, we have to consider that it's maybe not as secure as we would like it to have, right? It could fail. And still, we don't want to be able to fork any processes. And the nice part about Seccomp is that it's basically a mechanism which has been in Linux for a really long time. It used to be much simpler a couple of years ago, but there's lots of work being flowing into that. And Seccomp allows the process that is actually starting to tell the operating system, look, when I try to do something stupid, like in this case, trying to fork a process, don't let me. And the operating system is just going to tell you, oh yeah, that's what I'm going to do. So if Elasticsearch then tries to fork a process, the operating system will basically reject the system call. And the nice feature about Seccomp is that it works on many different operating systems. It has a different name on any operating system, like I think it's called jail on the Windows or OS X. And also it has different semantics. But the whole idea of not being able to fork processes or allowed to configure certain security policies exists under all those operating systems. So you literally have zero excuse not to include something like that in your own code. How does it work? Well, it's not super straightforward. And the reason for this is that a Seccomp policy, basically the rule set if something is allowed or rejected, is a BPF program. You may have heard of BPF whenever you run something like TCP dump. When you add up this small, tiny expressions of how to filter, that's BPF. BPF is a Berkeley packet filter. And this whole BPF infrastructure has seen a lot of uptake in the recent Linux kernel versions. So you can do things like performance measurement with that nowadays, and also add your own small programs for that. There's even 2 books which have been released in the last couple of months. And BPF programs are not made to look nice because they have to have some certain properties. Like they need to have a defined end. So for example, you cannot have a while loop in a BPF program, because if that was the case, it wouldn't end. Imagine that this little piece of program gets executed on every system call that is being made, which also means it needs to be really, really fast. And so you have to make sure that stupid constructs cannot be put into that one. So it's basically a direct acyclic graph. It looks like this, and you can see here that there's a check for a number of system calls that we don't want to happen. So this is Java, and again, we're using the Java native library to sort of write this kind of code in something that looks like Java, but then gets translated into native system calls. And this basically happens somewhere else in the code base, where we have a Linux syscall here. That one is a Seccomp syscall. That one has been added in more recent kernels. And there's also a PRCTR syscall, which used to be multiplexed into adding a so-called Seccomp policy. And we also check if setting this was successful. And if it was not, we abort. And again, this class, to set the Seccomp policy for all the operating systems, I think it has like 400 lines or something like that. It's not super complex. And again, I don't think you have any excuse to not include these kind of things in your own applications unless you really don't want to. And the idea of Seccomp is basically exactly the same than the Java Security Manager sandbox. You just allow or disallow certain calls. You can have much more complex Seccomp policies, like you could also filter opening certain files if you really wanted to. We could emulate the whole Java Security Manager functionality with the Seccomp policy, but it's more tedious to write. And so we just opted for not being able to fork processes because this is our biggest security nightmare. And of course, with the history, I hope I have enough time to cover that. The next thing is production mode versus development mode. So this is not so much about security, but about making sure that the system is configured the way it should be configured. And one of the features we have is so-called Bootstrap checks. Those checks basically check on startup if the system is set up to work as expected. Like most of the time, you set up a system, it works, but then you put load on it and it breaks. And then you're obviously unhappy and frustrated because this should have told you upfront that you may have to increase the number of file descriptors or anything like that. And this is basically what the Bootstrap checks and Elasticsearch are doing. We're basically making sure that once you run in something which we consider production, you have to make sure the operating system is configured in an appropriate way. And we kind of thought, how can we find out if something is supposed to be meant to run into production or you're just testing locally? And we thought, what is a good indicator? Turns out that Elasticsearch is a distributed system, so maybe the network is a great idea, right? If we are just listening on localhost, which is the default setup for Elasticsearch, we're just running locally, and this means this is not a production setup, right? In order to form a cluster, you need to listen on the network interface, and that moment it's production. We thought this is a smart idea, but, well, this is a wonderful software-defined network that everyone is using nowadays, right? And this one has definitely external IPs, so this idea didn't work. And there's another small additional check here where you can basically explicitly configure Elasticsearch to never form a cluster. It's a so-called single node setup. And this way, we could make this work with Docker, but we could still make sure that you're not running a cluster with those Bootstrap checks disabled. And those Bootstrap checks, it's a list of checks which can basically be divided between the operating system and the JVM setup. And we want to make sure that you have enough file descriptors that can be used. We want to make sure that that there are enough memory map pages configured, so you can memory map the files, which means you have sort of an in-memory access when you read them. And we also want to make sure that the JVM is properly set up, that you didn't try to be fancy and come up with a really stupid configuration for your garbage collector, like using a serial garbage collector or something like that. This is all the kind of things we can check when we get up and running. And the code for a single check is pretty short. This is just the check for the number of file descriptors, and if it's not matched, we can just exit and abort. Another really nice part of this infrastructure, and this is why I'm talking about this again for your own code, is that at some point someone figured out at the top there that if you run Lucene in a certain version with Java 8, with a certain garbage collector configuration, the JIT compiler produces corrupt code, which led to data corruption. And with this infrastructure in place, all we had to do is basically, okay, is this an Oracle JDK? Is this using a certain garbage collector version? Oh yeah, it is. And we can just stop starting. We can tell the user, please upgrade your Java, right? And having this kind of infrastructure in place, it was really easy to come up with something like that. All right, plugins. Who of you has to write a product where you're executing other people's code? Right? Plugins, extensions, scripting, these kind of things. Okay, who of you has this piece of code audited? All right, let's just skip that question. Like plugins are basically a security nightmare, right? You're allowing someone else to execute arbitrary kind of code. And for Elasticsearch, it's the same. However, if you don't want to maintain all the code for plugins that have ever been written, you have to provide some sort of hooks and extensibility so other people can write the code they want, right? For Elasticsearch, one of the core criteria for code is like, we only include it if it scales, if it runs on 1 node or 1,000. If you have a nice fancy solution for your own problem that probably just runs on 1 node, we will not include it, but we don't want you to exclude this solution on running on your Elasticsearch node. And this is why plugins are there. Each plugin can have its own jars and excuse me, can have its own jars and dependencies. This means that different plugins can have the same dependency in a different version. You may know this from something like Tomcat, where you have different web archives. You can do the same. The reason for this is that each plugin is loaded with a different class loader. And the other interesting fact about plugins is that they also run with their own permissions. So just because I really need reflection in this templating language doesn't mean that reflection is allowed across my whole code base, because we can basically contain those kind of permissions, and that is really important to us. And we are using this kind of functionality within Elasticsearch as well. There's something called a module, which is basically a plugin that uses the same isolation principles, but is always shipped with Elasticsearch. So if you start Elasticsearch, you can always see that there's a bunch of modules loaded, and the reason is we can contain them and configure their own permissions. The way this works is basically instead of having a system-wide policy, each plugin and each module can ship their own policy. And you can allow this for one plugin and something else for another plugin. This is how the policy files look like. This is to allow reflection. It's super intuitive, like access declared members, absolutely clear naming there, that this allows reflection. It's just something you really need to be aware of. This is used for one of our scripting languages, Mustache, and every template language basically works the way that it dynamically introspects an object, and if you want to do that, you just need reflection in Java. This is from another scripting language. This also uses a horrible security feature. It can create an own class loader, and creating an own class loader from a security perspective usually means that you create the ability to create arbitrary bytecode to run arbitrary code, which is really bad. So on top of that, we basically have a security mechanism that only certain classes can be used within this scripting language before we compile this down to bytecode. If there's another class being used, the execution is aborted. And you can go even further. You can see here at the top, there's a replacement, or there's a variable that one gets replaced during the build with a certain jar file. And only the netty dependency within our code base in this example is allowed to open network connections. And this is nice, because even if you write a plugin and you try to open a network connection from within your plugin, this will be rejected. You can't do it, because only this specific dependency is able to do it. You could go even further and only allow signed dependencies, but we're not doing that. Okay, last thing is Painless, a custom scripting language. And in order to understand scripting, it's basically sort of like a plugin, but much more dynamic. Imagine you have something like a bytes in field and a bytes out field, and you want to have a bytes total field. You could write your own custom plugin to do that, or you could just execute a script which just adds up those two fields. So it's a more dynamic way of allowing the user to do certain things. And Elasticsearch uses plugins at a couple of different places. And there's always been a script language in Elasticsearch, like Envel, something expression language, has been there for ages, but it turned out to be slow. Then we used Groovy, because Groovy had built-in sandboxing features that turned out not to be as sandboxy as we expected, and someone managed to execute arbitrary code via that. And over time, we kind of figured out we probably want to write our own language. Why? Because it's super hard to take an existing language like Groovy and add your own security features, but still remain fast. You usually have to compromise to one of them. And if you add something on top, it usually means it will never run faster than it used to be before. Also, you want to control the execution environment, the whole sandbox. This is what Painless is doing. You want to have really complex whitelisting and blacklisting. You want to make sure that only certain methods within a Java class can be executed. You really don't want to have regex. Like, if you do, people can do really funny stuff, right? Backtracking, things like that. And if you have your own execution environment, you can do really nice things like preventing endless loops. If you have a scripting language and your customer can execute arbitrary code, how do you make sure that something like while true gets aborted in time? How do you make sure that something like counting from 0 to long max value gets aborted? And this is something that is super easy when you control the execution environment. In Painless, we run through a loop 10,000 times. If there's more, we abort. Or detecting self-references to prevent stack overflows is also something. That's about it, right? Apart from that, not using the security manager, what's your excuse? It's pretty easy. It took us a lot of time to add this to an existing product, right? We only added this because the pressure was high enough from our perspective that warranted investing a lot of time to actually come up with a solution and fix all of those remote code executions for once and all. But if you have an existing code base, it's just a lot of work to port this, right? Same for scripting. There's no need to come up with your own scripting language if you don't have to. But again, for us, the stakes were high enough that we wanted to make sure be fast, be secure. Please use operating system features like Seccomp and don't write your own execution environment if you don't have to. Like, of course, you can always wrap runtime exec or something like that and hope it's as secure, but that's super unlikely. And if you have to allow plugins, please get them audited, get the infrastructure audited. It's, from my perspective, super, super important. All right. I think we should probably go over here. I'm almost done. If you want to know more, I have a couple of examples in this GitHub repository if you want to play around with the security manager and how to break it, how to make it work. I also have a lengthy blog post explaining how Seccomp is used in other products across the Elastic Stack. There's a couple of resources. I will tweet the slides later on, so you can take a look at them. And apart from that, I hope we have a couple of minutes left for questions. Thank you.
Thank you very much, Alex.
Thank you.
So first question, how big is the performance impact of using the Java Security Manager?
For Elasticsearch, first, we didn't really care because security was more important. Second, it was like 3% or 4% in our use case. So we completely ignored that one, to be honest. It's one of the advantages when you have a system that can scale out, right? You can always tell people, just use my hardware. It's great.
So how important are these measures when running inside Docker containers?
Sorry, can you repeat?
How important are these measures that you just presented when running inside Docker containers?
I think they're still as important because even inside a Docker container, you have probably the ability to execute arbitrary code. So why should you limit that when you're running within Docker? And also within Docker container, I mean, one of the things you can always do is not running as the root user, which you hopefully do by specifying user there. But I think no matter where you run, those measures are still important. You still want to make sure from an Elasticsearch perspective that you can call something like fork or vfork from a system call perspective. So there's no ability from the Elasticsearch side of things to disable this.
So Docker cannot be considered a good way of separating, applications from each other.
I would not consider Docker a security measure, no.
Okay.
Were there other new security mechanisms added in recent Java releases?
So there's still work being done on the Java Security Manager. For example, the checks that you saw, like the one in Java NIO file, has been sped up by 50 times by basically using Java code instead of using native code. This was needed for things like Graal, for example. So there's still development ongoing, but the excuse me, the Security Manager itself and its functionality is rather stable.
Okay. Another question that I found particularly interesting is there a way to initially generate policies, for example, by recording what an application does in a test run?
Yes. So this is the only reason for existence for the all permission, because you can set the all permission, can set a certain log level for the security manager, and you can see all the checks for every single permission that is being checked for.
Okay, maybe a couple more questions. We have a couple more minutes. One person asked, why are there so many data leaks because of hacked Elasticsearch installations?
That's a great question. You may ask yourself that we are constantly asking this ourselves as well. But I think one of the reasons is that people try to get up and running as fast as possible, and this always works without enabling certain security features. And they also assume that a software or a piece of software is secure because the environment around it is secured, right? You have firewall rules, whatever. And one of the things you should always do when running Elasticsearch in production is enabling security, is enabling authorization and authentication. Even if you just have 2 or 3 users writing data to indices, it still means that someone needs to know this username and the password. Also, enabling TLS makes a lot of sense. When you're running in cloud environments, you have absolutely no idea who is sitting next to you or who's even sitting on your own system. So using TLS sorry, makes a lot of sense as well. And when you run Elasticsearch, always enable security. It's pretty easy. And all of those leaks have absolutely not done that.
Okay. Next to last question, I want to ask one serious and one fun question. Why did you choose Seccomp and not SA Linux or AppArmor? Could you achieve the same thing with them?
You can achieve similar things with AppArmor and SE Linux, but both of those require support on the operating system, on Linux, right? Someone needs to install SE Linux, someone needs to install AppArmor, and this also means, depending on whether you're running Red Hat, Fedora, or Ubuntu, or Debian, you have to come up with different mechanisms. And with Seccomp, we also can be sure that no one can disable them, right? If you have only SE Linux support, someone may tell you, oh yeah, I really just disabled it, it's way too complex to set up. And then all of our security measures are going down the drain. With Seccomp and the way we implemented it now, it's always enabled and you can't disable it. And from our perspective, that's absolutely awesome.
So kind of the application limits itself instead of the operating system limiting the application.
I think that's also one of the things which is where the developers are the ones that are asked to do this, right? You're the only ones that know what your application executes and what is a good execution mode and what is a fishy execution mode, and you wonder, okay, this is maybe an attempt to get hacked. And I think it's the responsibility of the developers to sort of limit their own application to not do something stupid.
Okay, last question. Are there unknown knowns?
Sorry?
You talked about known knowns and known unknowns.
Oh, yeah.
Are there unknown knowns? So I know something, but I don't know that I know about them?
I can't come up with something. I should probably have a beer for that.
I should have told you before that I'm going to ask this.
So we can discuss it tonight, the evening with some
after some
alcohol.
spritz wine.
Yeah.
Thank you, Alex, for being here.
Thank you.